In this lesson, we're going to look at how the object-oriented approach that Java uses allows us to add behavior to our classes. For comparison, in procedural languages, we typically define our structured types and then create utility methods to operate on them. But this leaves a separation between the way that a structured type is represented in storage and the way that it is manipulated. Object-oriented languages move the code that operates on a data structure into the class that defines that structure. In this way, the association between the two is clearer. We know that the behavior is intended to work on that structure. Also, we can see, when we edit one part of it, what changes might be needed in the other part, so we're less likely to introduce bugs when we make changes to our code. To investigate this, let's look at a data structure that defines a day on a calendar. We'll start by creating a new project. Let's call the project Date1. Here is the Date1 class that contains the main method that we're going to use to create the program that's going to do things with our date. But the first thing we want to do is to create the date class itself that's going to represent this data structure. So we'll right-click on the Date1 package and go New Java Class, and we'll give it the name Date. This gives us the skeleton empty class definition for date, and what we need to do is to put into that the definition of the variable elements that will define the structure for a date. So it seems reasonable to think that we will have three pieces to it: a day, a month, and a year, and that we might use an integer to describe each of those. So there is our basic date data structure. We'll start calling them class now. And then to use it, we'll come into our program code that is going to be this Date1. And to use one of these things, remember the first thing we will need is a variable. So we'll call this meeting date, and we'll declare it as being of type date. Then we use that variable to refer to an actual date that we create in memory. So new date will create the physical allocation of memory that will have the elements month, day, and year within it. Then what we'll do, we will initialize the month to 2, the day to 29, and the year to 2012. February 2012 is a leap year, so the 29th is perfectly sound. And then we'll print out the meeting will be on, and then we'll print out the pieces, month, day, and year, of that data structure representing our meeting date. So we'll save the file, and then we'll run it. Meeting will be on 2/29/2012. So far so good. We know when our meeting will be. The next thing that we notice is that if we create a lot of these dates, having to initialize them by carefully stating that the meeting date .month is this, and .day is that, and the year piece is that, gets a little tedious. That's a lot of typing to do, replicating this date variable .month and so forth. So it turns out that one of the pieces of behavior that we can add to a class is a mechanism for initializing the objects that are created in memory, the instances of that data structure, if you will. The way we do this looks a little bit like a method. It actually isn't a method, it's called a constructor. What we do is we start off with the keyword public, and then we go directly to the name of the class itself. So our class is called date, and so we put public date. If this were a method, remember, there would be a return type declared in here, int or void or something of that sort. But the absence of that return type, plus the use of the exact class name, and this must be correct with regards to capitalization as well, tells the system that this is a thing called a constructor, a means of initializing objects of this type when they are created. And then, in the parentheses, we specify the arguments. So to initialize one of these, we'll need to provide a month, a day, and a year. So we'll refer to those as the ints m, d, and y. Then what we need to do is to take this particular object that has been created in memory and set the day, month, and year elements of it based on these month, day, and year, or m, d, and y variables that are provided in the argument list. So this .day refers to the particular occurrence of this day variable inside this object as it's being created. Now it actually turns out that it's possible to leave out this dot, but we're going to use that fairly consistently because it makes it a little clearer exactly what's happening. So now what we've done is to say that in order to create one of these date objects, we must provide it with a month, a day, and a year in this argument list in the constructor. And that means that this piece is actually going to complain because this does not provide those elements. So what we now need to do is to modify this so that we specify the month, the day, and the year, and that will be sufficient to initialize what's going on in this particular meeting date. So the next thing I can do is I can select these three lines, go to Source, Toggle Comment, and I can actually comment those out. If I save this code and run it, you'll see that it still actually works exactly as we specified. Just to prove that it isn't, that these lines didn't really disappear, let's change this to March, save it and run it, and you'll see that it really did pick that value up. I'm going to put this back to February. Well, the next problem is, suppose that somebody decides that they're going to change the date of this meeting. They decide that the 29th of February they're busy and they need the meeting to be tomorrow. So what they attempt to do is to increment the day field. Now, you can probably see where this is going, and it's probably reasonable to think that if you were manipulating somebody's date structure, you would be careful not to make this mistake. But many structures are more complex than that, and you wouldn't necessarily know what the internal rules for its integrity are. So let's just demonstrate that, of course, when we run this now, what happens is that we end up with a meeting scheduled for the 30th of February, which of course doesn't exist. Well, it turns out that using this mechanism of embedding behavior into our objects, into our classes, we can actually build a security mechanism that will help us to avoid this kind of error. So let's go and look at our date class again. What we really need is to be able to ask the date to modify itself by going to the next day. So what we're going to do about this is to add behavior to the date class that allows the date class to deal with all the complexities of a leap year. So let's take a look at this. What we've added is a method called nextDay. The nextDay method looks at how many days there are in this particular month based on the month and year that this object represents. Notice again we have lots of references to this dot month and this dot year. Those refer to the month and the year, and this dot day would refer to the day of the particular object that is currently being discussed. So the first thing that we do is to determine how many days there are in the month of the year that this particular date currently represents. So we have this method that we've just added called DaysInMonth, and that one is defined here. DaysInMonth takes a month and a year and then uses a switch statement and our little old rhyme about 30 days hath September, April, June, and November to work out how many days there should be in that month. So if the month is one of those 4 months that has 30 days, we set this integer value RV, which stands for return value, to 30. If it's not one of those and it's not February, then we set it to 31. But in the case where we're dealing with February, then we have to determine if this is a leap year. If this particular year is a leap year, then the number of days in the month will be 29, otherwise it will be 28. The computation for leap year looks to see if year mod 4 is 0, that means that if the year is divisible by 4, and the year mod 100 is not 0, that is to say the year is not divisible by 100, or, alternatively, the year is divisible by 400. Most of us think of leap years as being the ones divisible by 4, but strictly there are these little extra rules. So between these pieces of behavior, we can now determine how many days there should be in the particular month. Then what we do is to move the day counter to the next numerical day, but then compare it with the number of days that there should be in this particular month. So if this dot day has become greater than the day count we computed here, Then we set the day back to 1 and increment the month. The possibility is that we might just have wrapped around December 31st, so we have to look out for the month being 12, in which case then the month, if we had done this increment, needs to be set back to January, and we increment the year instead. So this behavior for next day has now become part of the definition of the structure of a date. Save that file and let's see how we use it. So what we now have is a date that is capable of recognizing how to create a reference to tomorrow. Here's some code to take advantage of that. What we're going to do is we're going to create another date object, and we'll set it again to the 29th of February 2012, and we'll call this one, we'll use a variable for this one, better meeting date. Again, it's a date type. Notice the way we refer to next day with this same dot notation that we used for the elements that were data elements. So in the same way that we said, I want to refer to the month that belongs to a date called meeting date, now we're saying I want the next day behavior that belongs to a particular date, the one called better meeting date. And this, by the way, is how this keyword in the date class itself knows which particular date object we're referring to. The variable here, better meeting date, will become the value this inside here. So that's to say that the day that we're incrementing here is the one that belongs to this, which is this, the better meeting date variable here. So what now happens is we tell the better meeting date, move to the next day, and instead of simply incrementing the day counter to 30 and producing a bad date, it should increment to 30, recognize, because of our tests here, that that's no longer valid, and do the necessary increments to wrap around and start the beginning of March. Let's save this file and check what happens when we run it. So we still have our existing behavior back here where the regular meeting is now apparently scheduled for a date that doesn't exist, February 30th, but the better meeting will be on 3/1. So in this lesson, we've looked at how we can add behavior to our structures, our classes as we're now calling them, and that behavior can therefore provide the facilities for manipulating our data structures in a closely coupled way that allows clear cohesion between the state pieces, that is to say the variables and the intended way that we expect to use those variables, and the actual behavior of the utility methods that we provide for them. And this is the foundation of objects.